Hi, chemistry students. I am making an explain video because everyone was struggle busing really hard during this lab, but also Miss Mannering, out of the kindness of her heart, is hanging out with me. So say hi to Miss Mannering. Hi, friends. So what I did was I went through and I did all the same calculations that you guys did for this lab. I took some absorbance values using the spectrophotometers that we had, made a graph, and I'm going to walk you through every single part of that. So the first thing that you had to do in this lab was you had to make your solutions, which most of you were able to do with pretty much 100% success. All the solutions that I saw looked really good. So we were using this M1V1 equals M2V2 formula to get at 9 milliliters of solution for every single cuvette, but they were at different concentrations. So our stock solution was at 0.5 molarity, meaning that there is half a mole per liter of solute in that stock solution. So to get to 0.1 molarity, we had to use 1.8 milliliters of our stock solution and then add water until we got to 9 milliliters, and that gets us to 0.1 molarity. For 0.2 molarity, we start out with 3.6 milliliters of our stock solution and then add water to get to 9, and so on and so forth. But like I said, you guys did that really well. We all got there. Once we got to our data collection chart, again, you guys were able to use your spectrophotometers well enough, and I know some of them are a little bit janky. So if your graph was janky and your data was janky, please use my data and you'll get a much clearer picture of what that data actually says when I start sharing my screen. But at 0.1 molarity, I got an absorbance value of 0.324. At 0.2 molarity, I was at 0.578. 0.3 molarity was 0.780. 0.4 molarity was 0.980, and 0.5 molarity was 1.150. In plugging all of that into Excel, well, not Excel, Google Sheets, and making a chart, thank you, Charles, for showing me how to get the equation in Google Sheets rather than Excel. We have this basic graph with a trend line, and this is the equation of that trend line. Now, to just compare that to what I already went over in the lecture before, y equals mx plus b format, in this case, we're going to use Beer's law and say that that's the same thing as a equals that funky little e times L times C. Now, X is going to represent C. E times L is going to be that slope here, and then Y is going to be the same thing as A. So when you plug in your unknown, you are going to plug in your unknown to the A spot and then solve for X to get your concentration. So my unknown value that I got when I plugged it into the spectrophotometer was, I believe, 0.673. So even just looking at where that should fall, given our data chart, our concentration should fall somewhere between 0.2 and 0.3, because those absorbance values for 0.2 was 0.578 and 0.3 was 0.780. So just looking at that pattern, I can kind of estimate where my concentration is going to be. So hold on. So now I'm going to walk you through how to create a chart on the Excel or Google Sheets. They're similar, but again, function slightly differently. So the first thing you want to do is you want to plug in your data with the concentration values here on the left and your absorbance values on the right. It's not important that you label each thing in your data columns, because you can do that externally when you make your chart. So you'll select your data by just clicking on the cell in the upper left, hitting Shift, and then clicking the cell on the bottom right. And then you're going to click Insert and select Chart. Now that chart is going to pop up and it'll kind of default automatically to a bar chart, but that is absolutely not the chart we want to use. We want to use a scatter plot instead. And mine is defaulting for some reason to 2 lines. It's using both of those data sets as an X, which is not appropriate. So in that chart setup here, you're going to add your x-axis, which for us, again, that's concentration, which was that first column on the left. So we'll select that. And then under series, you'll remove the X, that A column there. And what you see it's doing now is it is forming our chart for us, but there's nothing else there. There's nothing else written. So you have to get your equation next. So to do that, you're going to go over to customize and you're going to select series and you're going to scroll down until you see trend line and you're going to select that and scroll down a little bit more. And where it says label none, you're going to say use equation. All right, so that's going to give you the trend line for your data, and you do not need to click anything else for that. To make your chart pretty, you can go up to chart and axis titles, and you can select a title and input that information. So I might call this absorbance of Cu SO4. And then I'll go and select horizontal axis title, and I will call that concentration in molarity. And then I'll go and select my vertical axis title, and I will call that absorbance. So now I have a workable chart, which I can then sketch in my lab book. So now in terms of calculating the unknown value, let's see if I can draw on this. We're going to use this equation to do so. This equation again being y equals 2.05x plus 0.146. Now, our absorbance value that I got spat out at me was 0.673. So that value is going to plug in for y. So you're going to get 0.673 equals 2.05x plus 0.146. And then if you solve for x, that is going to be your concentration. So let me pull out my handy calculator and do that calculation real quick. And I get an X of 0.257. So as it turns out, initially my prediction that I told you guys over there that that concentration would fall somewhere between 0.2 and 0.3 was absolutely correct. That trend, that pattern is still emerging, and that's what our equation is showing us. So this is 0.257 molarity. And we can even estimate that on our graph. If we went approximately to 0.673, which is kind of right here-ish, we could find an approximation, right, on our graph of where that molarity is going to fall. Now, obviously, I'm a little bit off because I was just estimating, but the equation was able to give me a more exact value. So now moving on to what the lab sheet asks you to do in the lab report section. The first thing on that list is in this report, you'll need to include a title, an introduction, materials, methods, procedures, data table, any calculations, analysis, conclusion. So all of the normal stuff that you always put in your lab notebook. That graph, I do not need you to replicate it exactly. I would like you to sketch it and make that sketch kind of pretty, but you don't need to break out a ruler and make sure it's super perfect. I don't need you to do that. Just a sketch will do fine. In addition to your analysis paragraph, in which you will talk about how accurate was your data, what do you think went wrong, i.e. most of you should be citing the fact that our spectrophotometers are old and janky and there's chalk in them. In addition to all of that, you're going to answer these questions. So this is going to be your post-lab question section. First question asks you to determine the molar absorptivity of copper to sulfate with the correct units from your trend line equation, your unknown number, and its molar concentration with a brief description of how Beer's law was used to calculate the concentration. So Beer's law, again, is absorbance equals that funky little e, that's the molar absorptivity, times your path length, times your concentration. So what you can do here is you can use any one of your absorbance values and its corresponding concentration to do this. So let's say going back over, I wanted to pick 0.1 and whatever that data point was, 0.1 and 0.324. Then I would go back over here and I would plug in for my absorbance that 0.324, which was the absorbance value that the spectrophotometer spat out, equals E, the thing we're solving for, that's our molar absorptivity, times our path length, which is 1 centimeter. And that's a value that I'm giving you. You shouldn't have come up with that on your own. It said in the beginning of the lab, times 0.1 molarity. That's a concentration. So you can solve for E that way. Now, if you hadn't picked those numbers, you could use any of your other data points to do so, but that's an easy solve. And the reason I'm having you do this is because this value, this constant value, that's pretty hard to come by. You don't just know that off the top of your head. You can calculate it like this, or you could theoretically look it up for a specific concentration. But unless you have that value, you couldn't use Beer's law on its own to solve for any of the other ones, which is why we take these values in a lab situation in the first place. Now, some of you were struggling with this one. Describe the preparation of 500 milliliters of a 0.5 molarity copper 2 sulfate solution using solid copper 2 sulfate and water. So imagining for a second, I have solid copper 2 sulfate, which I absolutely do. It's in the back. In fact, I'm going to show it to you briefly. So this is solid copper 2 sulfate pentahydrate. So it looks like this. It's blue, it's chunky. So what I'm asking you is, how would you go about making a solution with this of a particular concentration? In this case, 0.5 molarity, which is exactly what your stock solution was that I just made. So what I did was I took a particular weight of this, which I had to calculate, and I dumped it in water and stirred it around until it dissolved. As far as calculating specifically how much of this I needed for that particular concentration, that is an equation that we went over in general chemistry last year or 2 years ago, whenever you took that. So we know that any particular molarity is equal to how many moles of solute over liters of solution. So here, I'm asking for 0.5 molarity. That's this value, 0.5. And that is equal to some amount of moles over 500 milliliters, which is the same thing as 0.5 liters. So if we solve for X, we can get how many moles of this solid stuff that I need to make that solution. So if I solve for X real quick, I get X equals 0.25 moles of copper 2 sulfate. Now I can convert that value to grams easily with the molar mass of copper 2 sulfate and hydrate, or pentahydrate, I mean, which is what this is. I would just have to figure out what that mass is on the periodic table. But this question is not asking you to do all of that math. It's not asking you to calculate anything. It's just asking you to tell me how you would go about it. So that description I just gave you is in fact the answer. I think some of you guys were trying to overcomplicate that one a little bit. Number 3 asks you to use your trend line equation. So again, the same equation that you got in that graph to calculate the absorbance for 0.25 molarity copper 2 sulfate. So in this instance, this is C, right? So if I were to plug that into my trend line equation, which was, hold on, which was this over here, the y equals 2.05x plus 0.146, that concentration C, 0.25, is going to get plugged in for X, and you're solving for Y in this case. Then number 4 is discussing any potential errors that occurred or other observations you made. So in addition to telling me, hey, guess what, our spectrophotometers were janky, is there a chance that you prepared your solutions incorrectly? Is there a chance that the cuvettes were janky? Is there a chance of whatever other error you thought might have taken place besides the fact that our spectrophotometers are pieces of garbage? So I hope that that cleared up some of the confusion on this lab. I know some of you are really stressed out about it. I'm not going to be here on Thursday or Friday, hence why I made this video, because I can't help you in ELT any day other than Wednesday. All right, so please let me know if you have further questions. Send me an email. I will answer you. Bye. Oh yeah, hold on. Let's say goodbye to Miss Mannering first. If I can figure out how my stupid thing. Say bye to Miss Mannering. Bye.